TEK 4A begins our linear data series talking about the correlation coefficient. The TEK says that students are expected to calculate, using technology, the correlation coefficient between two quantitative variables and interpret this quantity as a measure of the strength of the linear association. Whoa. Here's what I mean. We can measure the relationship between two items. The amount of ice cream cones we sell dependent on temperature. The amount of firefighters that are called to a fire depending on how big the fire is. Those are things we can measure. But we need to be able to talk about how strong that measurement is when we're using quantitative data. So we have a measure of this. It's called its correlation coefficient. Measures the strength and direction of an association in data. It is also called the R value. The R value. It is from -1 to 1. Somewhere along that spectrum, it's going to be your R value. So we know that all the numbers that are less than 0, between -1 and 0, are considered negative associations. And on the other side is positive associations because they're positive negative numbers. But the numbers that are in the middle here, about between -0.5 and 5, depending on the statistics that you're going to use, which is beyond the scope of this course, these are considered weak associations. That it sort of depends on the temperature for how much ice cream we're going to sell. Or it's going to be a really strong correlation. The bigger the fire is, the more firefighters are going to come. That's a strong association, almost a one-to-one relationship. Now what we're doing is really looking at scatter plots, trying to find the line of best fit and how good that line of best fit is. That's its correlation coefficient. It's the strength of that association. So what we're going to do is we're going to sometimes have tables or data that we can put into tables, and it will look something like this, a scatter plot. Now, in one of the other TEKs coming up here soon, we're going to talk about writing its line of best fit, which looks something like this. But what I'm more worried about for its correlation coefficient, or its R value, is the number right here, not R squared, R, the R value that I'm going to get when I run this correlation coefficient measurement. This 0.6692 would be considered a moderate positive relationship. It's not quite weak. It's more on the strong side, so maybe we consider it strong, but it's a positive number and it measures this association between these data points. Now the way that we do this for a problem, it's going to give us a bunch of data, the heights and lengths of several rectangles. What does the correlation coefficient, or R value, for this data indicate about the strength of the linear association between height and length of these rectangles? We need to decide if it's strong, weak, positive, or negative. So here's how we do it. I'm going to switch over to an app called Desmos. This app allows students to do linear regressions at home without the use of a yellow school calculator. So I've gone ahead and I've put in that entire table from the slide before, typed it in, all of the x's, all of the y's, and then I fill in the equation y equals mx plus b. But instead of an equal sign after the y1, m, x1, and b, I need to put a tilde, which is like the wavy equivalent to number. And when I do that, Desmos automatically finds the association between this data. If I zoom out, it's got the coordinate points for you here and the line of best fit between these triangles. Now, I also know that this R value down here, I can't really point anymore, but it says R equals 0.155. Well, that's a positive number. So I automatically know that since my R value is 0.155, I know that it's not one of these negative numbers. It's not negative, it's not negative, so it's not A or B. And I know that this number is closer to 0 than it is to 1 on a scale, about right here, which would make it a weak positive correlation or association between the height and length of these triangles. Again, I'll show you those numbers. We look at this graph. Here's all the data points. We've created the line of best fit, but I'm more worried about this R value here, 0.155, and determining where it is on my scale from 0 to 1, or from -1 to 1. This would be a weak positive correlation. Now, this can be done on your graphing calculator, and students in class who want to learn, we will teach them the stat edit and turn on the correlation coefficient. It's a lot of steps, and we don't have graphing calculators to send home with your students, so we teach them on the website Desmos, which is free, and they can use at all times in our class. As always, we empower, we impact, we love. We are Skeeter Nation.